First of all, welcome, .NET developers. Like William said, it's probably for some of you your first Java conference you've ever attended. But welcome, and hopefully you're getting something good out of it. I'll do my best this time around to give you some good information as well. My name is Dave Tillman. I work for Pivotal. I work on the Steeltoe project, open source project. I'll describe a little bit of it today. And I've been on it from day one, so I have quite a bit of experience with it. Just a show of hands, how many are actually using Steeltoe today? Okay, awesome. How many have never heard of Steeltoe and it's very new, so just a handful, okay. And how many of you are happy with Steeltoe? Okay, those of you who didn't raise your hand that are using it, see me afterwards. I want to know why you're not happy or what's causing problems, because we want to make sure your experience with it is good. So see me afterwards. Okay, so what are we going to do today? Let's talk about, this basically is the framework that I have, or the outline that I have. We're going to spend some time talking about, real quickly, cloud native frameworks, both Java and .NET. And you may be asking yourself, why is he talking about Java-based frameworks? As, you know, this is supposed to be a .NET session. Well, it's because a lot of the things we do in the Steeltoe packages, we try to keep parity with our Java cousins over in the Spring Boot side. And in fact, you'll see as we talk about some of the packages, and specifically today we're going to talk about monitoring and management, you'll see that we've done a lot of things to make the behavior and the capabilities that you have in the .NET world pretty much mirror what you have in the Java world. And we also do the same thing with things like config server, Eureka, all those sorts of things. Our belief is that the world, most of our customers, as William mentioned, most of our customers at the enterprise level are both Java and .NET. And we don't feel as if companies need to make a decision. Are we all going to be all Java? Are we going to be all .NET? We think those two worlds should coexist well together. So we spend a fair amount of time talking about and thinking about patterns that should be common and ways in which the two worlds should integrate with one another. And I'll briefly mention on some of those. And so today, when we talk about management and monitoring, we think in that way, meaning that you should be able to monitor and manage your Java microservices, your .NET microservices, see them holistically in a nice, easy way. And that's what we'll talk about and show today. And so that's why you'll see me referencing a lot of the Java packages as I go through the presentation. Of the many areas that we could focus on with Steeltoe and Spring Boot, Spring Cloud, we're really only going to focus on what I refer to as the M&Ms, or the management and monitoring areas of the packages. And then hopefully, if I can speak shortly and get through the slides rather quickly, I'll spend most of my time looking at a demo. And it's a demo of a Java and .NET application, all interoperating with one another, and we're going to monitor and manage that as a cohesive unit. Okay, so let's first start with the Java side of the world. So for those .NETers out there, if you've never heard of what your Java guys or your Java cousins are using over in the Java world, it's probably something called Spring Cloud or Spring Cloud Services. And these are basically a set of packages, a set of libraries, set of tools, set of servers that you as an organization can deploy to enable you to build distributed microservices style applications and run them on the Cloud Foundry platform with ease. And they're packaged up in a nice way for you to deploy them on PCF. And you get a bunch of libraries, or you have access to a bunch of libraries that give you things like service discovery or centralized configuration, or, for example, circuit breaker patterns that you can use for monitoring, or even security-based patterns that you can use, OAuth 2. And these are all what your Java cohorts are using over on their side of the house in order to build these highly distributed microservices-based applications. And that's called Spring Cloud or Spring Cloud Services. If you're interested, there's a nice little website that you can go to that will give you more detail. You can drill down into the Spring Cloud project. It's an open source project. You can drill down into it and see all of the different sub-projects within it, one of which would be Spring Cloud. So take a look. A lot of good documentation over there. So what's the equivalent on the .NET side? Well, that's the Steeltoe project that I mentioned, or that has been mentioned earlier that I mentioned as well. And that is an open source project that was started about 2 years ago. It's open source at that location. There's a website called steeltoe.io that has docs for it. There's a Slack channel that you can reach us on if you have issues or you want to talk about things or you want to contribute or whatever you may want to do. It's completely open source. And it's a framework that basically does two things. It simplifies building .NET applications or ASP.NET applications on Cloud Foundry. So we have a lot of things that enable you to, for example, deal with security, connect to back-end services like databases or Rabbit or whatever it may be. We make it very easy for you to bind those services into your .NET application and make use of them within your application as well. We also have, this is where we begin to integrate with the Spring Cloud packages, Spring Cloud services. So we have, again, clients for the config server, for Netflix Eureka, so if you can do service discovery across both your Java and .NET apps. You have a Java microservice and you have a .NET component that needs to look up that service and make REST calls to it. You have a nice common service repository that you can access as well. And then the list goes on and on. Circuit breaker, distributed tracing are also now part of the Steeltoe packages. We support both .NET Core and .NET Full framework. So if you have, if you're building a new ASP.NET Core or .NET Core type applications, or you're building, or you're maybe lifting and shifting ASP.NET 4X type applications, most of these components can be used in either or of those packages. So you can drop these packages in, make use of them, maybe simplify your move onto the platform without too much trouble. They're not very invasive. Okay? So what I want to do today is I want to focus on a few of these areas. First of all, I want to focus on management and monitoring, both from a Java perspective and a .NET perspective. And then I also want to focus on circuit breaker and the distributed tracing features, and also talk about metrics. Oops. So I like to group these, I'd like to basically call these areas, these developer tools that you can drop into your application as the M&Ms. So the M&Ms that you can grab, drop into your application to basically give your .NET application observability. And it also holds true for the Java side of the world. The Java developers can do the same sort of things. And so one of the packages that you can drop in gives you what we refer to as the management endpoints. These are REST endpoints that basically automatically add monitoring and management endpoints into your application, just pure REST endpoints, that allow you to do things like look at the last 100 requests into that app instance. You see all the different information that was done. Or you can look at health of that application. You can look at, for example, you can adjust the logging levels within that application, meaning you can see all the different loggers that have been established in the application, and then you can dynamically adjust the level of those loggers up or down depending on your needs. Let's say you're diagnosing a problem, you want to capture a set of logs, capture them, take a look at them, you can do that automatically. And again, these all work across, these REST endpoints work the same across both Java and .NET. Also, recently we added to the Steeltoe packages, we added open census support, where you can capture now application metrics and runtime performance data out of your ASP.NET Core or your .NET or your ASP.NET 4X type application. And then you can export that data out onto, in the case of the PCF world, you can export that metrics out onto the Loggergator Firehose so that any package that's able to read that data can now show it and visualize it and give you access to it. That's true also, of course, on the Java side. Spring Boot has the same thing called Spring Boot and the micrometer packages, and they have exporters as well for the same thing. So now you can funnel both your Java metrics and your .NET metrics onto the Loggergator and have a nice, consistent, common view of all the metrics in your applications. We recently added distributed tracing, basically the ability to capture and correlate application traces, but do it in a distributed fashion. So now, if you if you have a distributed microservices-based application, you have a request coming into the and the request follows and goes through a bunch of microservices, some of which are Java, some of which are .NET. We have the ability now with both Steeltoe and using Spring Cloud Sleuth to basically have your applications instrumented so those traces are captured, and if you want, you can export them out to a common server for viewing. I'll be demonstrating, for example, the ability to do that with Zipkin being the back-end server. And then in both cases, we have this support for Hystrix circuits and Hystrix circuit breaker patterns, both in the Spring Cloud Hystrix package for Java and the Steeltoe Hystrix package for .NET. This basically allows you to model your external dependencies, encapsulate them in what's called in a command pattern, and then when you issue requests to these external services, these external microservices, we're able to capture status and performance data on a per command basis, and it gives you visualization of what's going on within your distributed app. So all four of these are areas that I'd like to drill down into, and as developers, how do you make use of these? How do you implement them, and how do you what kind of features and capabilities do you get? So in the Java world, those of you who are maybe Java developers or have messed around with it a little bit, you just drop in a Spring Boot starter actuator package, and then once you have that, you've got all the actuators put into your Java application. In the case of Steeltoe, if you want to do this in a .NET Core application, you add the Cloud Foundry Core nugget, or if you're in a 4X application, a SysWeb or an OWYN-based app, you drop that in. What do you get? You basically get a set of REST endpoints. This is the list of them right here that automatically integrate with the Apps Manager, Pivotal Apps Manager for Cloud Foundry. So you can look at things, for example, detailed health information. Here's that trace buffer that I mentioned. Here's where you can dynamically change the level of your logging output. In fact, you can even do dumps. You could take a heap dump, or you could take a thread dump of your application, again, if you're trying to diagnose an ongoing problem. And then there are a few additional ones down here that are exposed that aren't really visible in the Apps Manager, but you can add them into your application and expose them as well. And again, they both are for Java and .NET, so you have both worlds covered. When it comes to application metrics, the metrics are again provided in the Java world just by adding the actuator starter. .NET Core, you use the endpoint core nugget or endpoint web, depending on which type of application you're doing. Once you do this, and you have to write a little bit of code, and I'm going to show that here in a few minutes. Once you do that, you automatically expose the metrics endpoint in either your .NET or Java application, and you automatically start capturing both JVM and CLR type metrics, heap usage, generations that are going on, GCs. You also are automatically capturing some common ingress and egress points of your metrics around common ingress and egress points within your application. So when a request comes into a microservice, we capture the time it takes for that request to go in and out of that microservice. All of that stuff is rolled up, and optionally, you can then export that set of metrics to the metrics exporter. In the case of .NET Core, you add these sorts of things. You automatically get it with the Spring Boot. When you add in Java, the Spring Boot metrics forwarder is automatically added by the Java build pack when you build your application in Java. Okay. When it comes to distributed tracing, again, this is the idea that you've got a distributed application. You want to, upon entry, you want to start a trace of that request that goes through your application. So you need a way to correlate that request as it goes through all your microservices. This is commonly called distributed tracing. Within each of the microservices or within each of the components of the application, the trace is captured and then uploaded potentially to a common server where it's all put back together, and now you can visualize it. I'll be demonstrating that, hopefully, if we got time here in a little bit. If you want to do that in the Java world, we've got a package called Spring Cloud Sleuth that the Spring team has developed. In the case of .NET Core, we've got a tracing core package. Right now, we don't have .NET 4X support for this right now, but we'll be looking at adding that in the future. And this is some of the things that it does. One of the things in both cases, Java and .NET, is we automatically then begin to add what are called the trace ID and the span ID to any log messages that are issued out of that application. Why is that useful? That's useful for log correlation. If you're trying to debug a particular application or a particular request that's come into your system and you want to drill down and look at all the log messages, right, you could go to a log aggregator, enter that trace ID, and search, and you'll get up basically all of the log messages associated with that specific request. Enables you to see and debug, and I'll demonstrate that here in a little bit. You get that automatically just by adding and doing a little bit of lines of code to your application, both of Java and .NET. And then we automatically instrument, again, the common ingress and egress points within your application. We automatically propagate the trace context, so if you issue an HTTP request to some outbound service someplace, we'll automatically take that trace ID and pass it along down to the downstream component so that it is able to pick it up and continue adding to that trace. And by the way, this is compatible across Java and .NET. So if you have a mixed environment, Java and .NET, you have microservices talking to one another, this all works seamlessly within Java and .NET world. And then optionally, you don't have to do this. You may just want to use log correlation, but optionally, if you'd like to capture the trace itself and have it sent into, say, for example, a Zipkin server, which I'll be demonstrating, then in the case of Java, you add this particular Maven package, and in the case of .NET, you add the exporter core, okay? And then the last area that it falls into the M&M area is using Hystrix. Hystrix is a package that was developed, originally developed by Netflix. They use it internally for fault management and fault-tolerant services within their distributed system. It's essentially used to isolate points of access to remote systems. And you're able to, with this pattern, you're able to leverage some very common patterns used for in distributed applications, like the bulkhead or circuit breaker pattern within your application. The basic idea is you create this command wrapper that represents an external service that you're going to invoke or make a call on, and you create this command class, and you derive from this base class, and this base class adds a bunch of functionality, including the bulkhead and circuit breaker pattern, to that command, okay? And then within that command, you get to write the code that actually invokes the remote endpoint, or in the case if you begin to see a failure, fall back into some other activity. So, do something in the case of that, for example, that external service being down or not responsive. The really cool thing about this is if you follow this pattern and you use this Hystrix component, we gather metrics and usage information, status information of those circuits. Think of each of those external dependencies as being a circuit, and we capture metrics, performance metrics, and status information for all of your circuits. And again, this works both across Java and .NET, works the same way consistently. And I'll be demonstrating how this integrates with the Hystrix dashboard on PCF, so you can see how that works in the Java .NET world. All right, so here's my demo. Hopefully I can get through most of my demo. So I've got a Java-based microservice called the shopping cart. There's an endpoint called checkout that we're going to hit. In between, we've got the .NET order process. And on the back end, we've got another Java microservice that handles pay processing. We've enabled all of them with the management endpoints that I mentioned earlier, both for Java and .NET. We also are using the Hystrix circuit breaker to make the request of the back-end payment processing service. So the Hystrix dashboard is going to give us a status of the outgoing circuit that we're using to communicate with the pay processor. We've got some databases that we have attached to our .NET process. And so we're going to monitor the health of this to make sure that it's up and running and accessible. And then we're going to look at basically the endpoints, the M&M endpoints, the REST endpoints in the apps manager on PCF. Basically, we're going to view these. And we're also going to look at metrics coming out of this entire application in PCF metrics, and we'll do some log viewing and log correlation of the distributed traces that are flowing out. And then we're actually forwarding the traces out of each of those applications into a Zipkin server, so we'll be able to actually drill into the Zipkin server and look at individual traces as requests go through the system. Okay? So, if the demo gods are with us today. Okay, so I started up, when I got up here, I started up an application that's just hitting the checkout endpoint, right? So making requests constantly going through the application, and it looks like it's still running, so that's a good sign. So first, let me look at the code necessary to get those REST management endpoints up and running, okay? So Steeltoe, first of all, the thing you have to do is you have to add this line, which adds the Cloud Foundry configuration. So what we do is we automatically parse the VCAP services and the VCAP application data. We parse that and bring that into your configuration that you have running within your application and make that information available. Of course, the Steeltoe packages make use of that, as you might expect, but also you can make use of that information as well because it's just dropped right into your configuration. Then within, when you're configuring logging, we have a dynamic console logger that you can drop in that instead of, basically is a wrapper around the normal console logger that's provided as part of .NET Core. And it basically allows us to do the log level manipulation and viewing of the application. So you have to add that in as well. Then within your startup class, in this case, remember we're using, we have a MySQL database attached to the .NET application. So we're using the connector, Steeltoe connector to enable the connection to the MySQL database. And as part of that, it also adds a health contributor into the service container. That service container, or that health contributor now is going to be what's responsible for checking the health every time the /health endpoint is called by the apps manager. You can also write your own custom health contributors as well. So if you have some other things or other ways of determining the actual health of your application, it's very simple to write your own custom health contributor as well. I'm not going to show you the details, but you can take a look at this later. And then the last thing you have to do is to get the actual, or not the last, but the second to last thing you have to do is you have to add the Cloud Foundry actuators. These are basically the endpoints added into the service container that are going to handle each one of those different REST calls that I showed you earlier. Then if we scroll down below and we go to here, we see we also then have to add the middleware into the pipeline so that for each one of those REST calls, we have the correct processing taking place. And you do that with the normal app use Cloud Foundry actuators. All right, so what do you see? What do you actually, once you do that, what actually happens? Okay, so the first thing, notice here are all my three servers. I've got the all three of the processors. Shopping cart and payments are Java-based applications. Orders is .NET, a .NET Core, ASP.NET Core, and then notice I have a Zipkin server running as well. When you let's take a look at payments processor. First thing that happens is if you have the actuators enabled in your application, you'll see a little extra symbol over here. In the case of a Spring Boot application, you see this, okay? And then also you see some additional menu items that pop up in the bar up here as a result of having those actuators enabled. So if we go back and take a look at our .NET application, notice we have a Steeltoe symbol up here. That's your sign that the actuators are actually enabled in here. Then if we drill down, we've got one instance running. We can click down, and here's where the health check information shows up. And we can see that we basically have 3 health contributors in this particular health check. We have the custom one, which just basically says I'm always up, but you could write whatever code you want behind it. We also have a disk space checker That's what you get by default if you don't do any other additions. And then notice we have the MySQL health contributor as well. The MySQL health contributor is doing nothing more than pinging the database every time a health check comes in, making sure that the database is present and available. Here's where the trace information is. The trace endpoint will show me the last request, basically the last 100 requests for all process, in this case, process order requests. You capture the request and the response data. You also get a timestamp. That particular request took 951 milliseconds to finish. Notice you can also select on a per instance basis that trace buffer. Here's probably one of the most asked for pieces is the logging levels. So this is now, we're showing essentially all the loggers that are active within that particular orders processor, and we're seeing that there's 120 total loggers up there. And so, for example, I can go in here to orders, and this is the orders controller. Right now it's set to info. I can just select debug, and now I will have turned on debug logging for that, for all instances of the process order. I can capture a log, and then I can easily go back and turn it back down to info level, again, when I'm trying to diagnose a problem. Again, this works consistently across both Java and .NET applications, so you have a consistent way of dealing with these things. And let's see, over here on settings, notice we have in this area called Steeltoe Info, you can drop in Git information, so every build that you do, you can drop in the Git info, and you can easily go in here and see what when the build was done, that sort of stuff can be dropped in. And then in the mapping section, we can see basically what endpoints or routes have been enabled within this application. So we query and look for all the routes, and in fact, we can then demonstrate that in this case, what's going to act on that particular route, what the controller is, and what the action method is. So some people find that to be quite useful. Okay. And all of this, like I said, is also available in Java-based applications. So if we go over here where we just were, take a look at view mappings, these are all the endpoints available in that particular Java application. Couple things here I want to show you is here's I don't have this enabled in the .NET application, but you can get this in a .NET application. You get a thread dump. So if let's say you've got an app that you are kind of wondering, you've got an instance that you're kind of wondering maybe it's starting to get hung or something's not quite right with it, you could take an instant snapshot of the Java threads, and of course with each one of those you can take a look at the current stack trace of where that thread is. So you can begin to diagnose problems. You may have threads that are hung, for example. You could do the same thing on a .NET application, but only currently when you're running on the .NET framework as opposed to the .NET Core runtime. Actually, that's not true. Only if you're running on a Windows machine, not in a Linux container. Okay? You can be running in a Windows machine, a Windows cell, but you can be running on .NET Framework or .NET Core. Your app can be running on either, and you could still get that functionality. You just can't do it in a Linux container today. We'll be adding that hopefully down the road. Okay, so that is REST endpoints and how they integrate with the apps manager. So let's take a look at metrics now. So quickly, let me drop into, I'm going to use PCF metrics. First, let me show you the code. It's pretty straightforward. Oops. So only thing we have to do in code to turn on metrics is basically after we've added the Cloud Foundry actuators, we add the metrics actuator, and then we add the metrics forwarder, exporter. This will then take the collected metrics, put them out onto the Loggergator Firehose. So in this case, PCF metrics can pick them up and display them and view them. If you don't add that second one, you basically have access to the /metrics REST endpoint to capture metrics or look at metrics. And then you have to add the metrics actuator into the pipeline. And there's probably some configuration stuff, but I won't. Since I'm short on time, I'll go quickly. Yeah.
So with these REST endpoints,
There's no integration into the platform other than what you see in the apps manager right now for those health endpoints that I'm aware of. There could be some other work going on by some other teams in that respect. So see me afterwards, and we can dig into that for you at this point, but nothing right now.
Will it not scale?
It won't. There may be some, honestly don't know within the platform itself. That would be a platform level thing. Within the apps manager, it doesn't do anything. It just displays it. Okay, so if we look quickly at PCF metrics, here, for example, is the shopping cart. You notice we have things like the heap usage. We have the time, the response time for the checkout particular endpoint. And we have basically the same sort of capability over here in the .NET world. Let me, for example, add the CLR Gen 0 counts. And let me add CLR dot memory usage. And now you see, for example, we have that plotted over here. We also have the ability to add let's see what else we got. This is the process order endpoint, and these are basically the request count to the process order endpoint that are all returning 200s. And if you're getting 500s or whatever, you would see metrics associated with that as well. Okay. Hystrix. So Hystrix, this is the dashboard that you can see within the PCF environment. What we're showing here is essentially the payment service command. This is the wrapper around the payment service that the .NET application is issuing to the remote service. And we see essentially the performance of that particular circuit. If we were to do something fun like go over here to the payments processor and stop it, we now see that this circuit becomes open. We see that we're starting to see failure requests. Basically 100% are starting to fail. So again, you get visualization of what's going on. You get some metrics as well. If we go over here then to restart it, we'd see that essentially that circuit breaker would close, and we begin to see a nice flow of data going back through it as well. So again, another tool in your package that you can use for monitoring both .NET and Java-based applications. Again, this works across both Java and .NET applications as well. And then the last thing, real quickly, that I will show is Zipkin. So all of the trace information is being collected and sent into this centralized Zipkin server today. And so we can do things like, for example, see all the dependencies. So Zipkin will analyze all of that trace information and will be able to give you a dependency graph that shows automatically the microservices in your application and the flow between them. Remember, orders processor is the .NET app. The other two are Java. And then we can also drill down and look at, say, the last set of traces. I'll look at the newest first, do find traces. And here we've got essentially a trace coming in. And notice that it basically shows the request coming into the shopping cart. That request took 801 milliseconds. Let me see if I can make that a little bigger. Took over 800 milliseconds, calls out to the order processing, and then finally into payments. And you can see a breakdown of where all the time is being taken. You can also drill down into a specific piece of the request. And there's a bunch of additional information provided here for you to dig into that's captured on a per trace request basis. Again, timestamps and so forth that becomes sometimes when you're trying to diagnose a problem becomes quite useful. So the way you typically would use some tool like this is you'd see a request in the log that has a trace ID of 123. You would take that 123, come over to a tool like this, drop it in, get the detailed information of the request, what was going on, and maybe an exception took place, or maybe whatever. You want to capture whatever information you'd like to do. You can append to all of those trace components. You can append append your own information as well. So quite nice. Okay, we were short on time when we started. I didn't get a chance to show you some of the additional stuff. If you have questions or you're interested, come in and see me afterwards, or see us outside in the hallway, and I'll be glad to fill in any details that I might have not been able to cover. Thanks.